Hello and welcome. This is a lesson on chemical reactions. Get ready to learn. I love watching fireworks. Why is this important? Well, predicting what will happen when two or more chemicals are combined would be a good thing to know. You don't want things blowing up. You can tell how much of each chemical is needed to produce a certain amount of the new chemical compound. It's all math. Did you know? Chemical reactions happen when atoms break free of chemical bonds and form new substances with new chemical bonds. So you're going to get something different. Chemical names, by their common name or by a shorthand symbol. Using mathematics, we can predict what will happen in a chemical reaction by counting the atoms and balancing chemical equations. We know this one. This is water. We can describe a chemical reaction or a molecule using words. Dihydrogen monoxide. Two molecules of hydrogen gas react with one molecule of oxygen gas to produce two molecules of water. So we have two hydrogen and one oxygen. Shows we can use a shorthand. Two molecules of hydrogen, one molecule of oxygen, O2. Both hydrogen and oxygen like to hang out in pairs to produce two molecules of water, two molecules of H2O. Or we can draw a picture or a model. Helps us to visualize what's going on. And we'll talk more about this later. Periodic table. Chemical equations. The chemical symbol is made up of a single letter or two letters. These here are two letters. Two letters because after you get to 26, you run out of letters. The first letter is always capitalized. So here in iridium, you have I, capital I, small r. And lithium, L, capital L, I. Beryllium, capital B, small e. Some of these names might not be obvious. They come from the Latin and the Greek words. We'll get to that. Okay, we got a lot going on here. You can watch this over and over and find that what you start with has to equal what you end with. So the total number of atoms on the left side and the total number on the other side, what you start with, what you end with, they have to be equal because you're not going to pick any up or lose any. You're not going to create any nor to destroy any. You're going to rearrange these in a chemical reaction. So we can predict knowing that the reactants must equal the products. The reactants is what reacts The product gives you what happens after. Product, produce, that kind of thing. The law of conservation of mass says before and after, these have to equal. Now this keeps going on, but you'll see that the number of P is 4. 4 times 1 is 4. You got 10. There's a lot going on in here. This is going to keep going on until you find out that the number before and the number after are going to be equal. 4 before, 4 after. 16 before, 16 after, 12 before, 12 after. It's got to do with the math, and we'll talk about that in a little. No atoms are created or destroyed in the reaction, and it can be used to predict the outcome of the reaction. If we combine these two things, we're going to get this in these ratios. All right, let's do something easy. In a chemical reaction, substances present at the beginning are the reactants. They react. The products are found after the arrow. So we got reactants here, products here. Remember we talked about hydrogen and oxygen hanging out together. So one molecule of oxygen is H2. Excuse me, oxygen is O2. Hydrogen, H2, hydrogen, H2. Now, on the other side of the arrow, we've got oxygen with 2 hydrogen, oxygen with 2 hydrogen. So let's count them up. We have 2 of the red ones. On the left-hand side, what we started with, we have 2 of the red ones when we're finished. We have 1, 2, 3, 4 hydrogen at the beginning as a reactant. We have 1, 2, 3, 4 when we're done. You'll notice that this large 2 talks about how many molecules you have. This large 2 talks about how many molecules you have. If there's not a number there, the number is 1 because you have 1 oxygen. Now the smaller numbers tell you how many in each of the molecules. You have 2 oxygen in 1 molecule. You have 2 hydrogen in 1 molecule, but you have 2 molecules. I get it. Gets easier. Atoms recombine to form new things, new molecules. So these break apart, these break apart, these break apart, and they form something different. This may help. Conservation of mass. Here we go again. In a reaction, no new atoms are made or destroyed. The chemical bonds break. The atoms recombine in a new way. New bonds are made. So here we have CH4, methane, oxygen, oxygen, gives carbon dioxide and water. So that's in words. Let's look at the atoms themselves. Remember I said if there's no large number out in front, the number is 1. So we have 1 molecule of CH4. We have 2 molecules of O2, 1, 2. After the reaction, we have, remember, 1 CO2 and 2 H2O, 1, 2. Let's count the atoms. 1 black one, 1 black one. 1, 2, 3, 4 white ones. That's the hydrogen. Notice the 4. 1, 2, 3, 4. 1, 2, 3, 4. 2 times 2, 2, 3, 4. So in each molecule of H2O, you have 2 hydrogen, 1, 2. And we have 2 of those molecules, 1, 2. So everything you start with, you end with. Nothing is made or destroyed. Heat energy is almost always involved. Energy is sometimes given off in a reaction. It's called exothermic. Thermic meaning heat, temperature. Thermometer, remember? Exo meaning to give off or to leave. So the energy is given off. Energy is sometimes absorbed. Endothermic. Heat comes in. This is a cold compress. You combine chemicals in here and it gets cold. It's easy to remember. Exothermic, exo meaning exit, to leave. So energy leaves. Endothermic is the other one. Okay, we get a couple different kinds of chemical reactions. When atoms are combined chemically, the reactants are what you start with. Here we got 2 different chemicals, 2 different elements, A and B. So we start with A, we add B, they react, and you get AB. They combine. The products are the result of the chemical reaction. So we have reactants, the chemical reactions, what happens when you combine them, and you get the products. There are different kinds of reactions, though. So we have combination, we have these 2 breaking apart. We have A and B together, and then they combine with C in a chemical reaction to give now A and C, but not B. So A breaks up with B and joins with C. And you have a double replacement. A is with B, C is with D. You have a chemical reaction. Chemical A combines with C and B combines with D. These are typical chemical reactions. But you'll notice that no material is destroyed in any of these reactions. No new material is created. In other words, there's not A, B, and R over here. So why is this important? Predicting what will happen when 2 or more chemicals are combined would be a good thing to know. You can tell how much of each chemical is needed to produce a certain amount of the new chemical compound. It's all math. There's your lesson on chemical reactions.